Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistants, and today we are looking at atomic and ionic radii. And more important than that, just as important at least, is knowing the trends of the periodic table. So arrange the following atoms in order of increasing atomic radius. So we need to find the increasing atomic radius for sulfur, chlorine, and fluorine. So let's have a look at a periodic table real quick. This is a periodic table from ptable.com. I highly recommend you use it. It's interactive, but I just took a screenshot of it so that we could use it in this example. So we have fluorine, chlorine, and sulfur that we're trying to identify which one has the greatest radius, which one has the least. So the way atomic radii form, the way the trend on the periodic table is that it's going to go down the periodic table. So if you note on the side here, I'm drawing a little arrow. So francium would be larger than cesium, which would be larger than rubidium, which would be larger than potassium, and so on. But it also goes from right to left across the top. So what looks like here is that neon is going to be larger than fluorine, which is larger than oxygen, which is larger than nitrogen, which is larger than carbon, and so on. So let's find our specific elements. We're looking for sulfur, chlorine, and fluorine. Okay, so that's our cluster right there. And if we follow the trend, we should be looking at, first and foremost, it looks like it should be sulfur. Sulfur should be our largest atom because it's furthest down the period and furthest to the left in terms of the groups. So the next largest would have to be chlorine, and that would make fluorine our smallest. If you just look at the trends, if we were to just take a second and look at sort of a micro trend here, we would be looking at it traveling like that and then down. So we're looking at fluorine is the smallest because it's the furthest in the upper right-hand corner. And then you would have between chlorine and sulfur, chlorine would be smaller than sulfur just because it's further to the right than sulfur is. So having decided that, we can come back over here and go ahead and write down that fluorine is less than chlorine, which in turn is less than sulfur in terms of size. Increasing atomic radius, so we're starting with fluorine and ending with sulfur, sulfur being the biggest. You could just as easily have written it like FCl and S because it's already indicated that it wants increasing. So you start with the smallest and move to the largest. If it had asked for decreasing, we would start with sulfur and move to fluorine. So now we're looking at, we're going to look at some ions instead of atoms. It's an important distinction between them because the trends are slightly different. In fact, they're majorly different. So the big thing let's go back to our periodic table and let's get rid of some of this junk that was written over here. Okay, so when you're looking at ions, we're going to look at the trends of ions. Now, the most important trend with ions is that it's going to go down the periodic table. It's going to go, the ions get larger as you move down the period with respect to each group. Now, in terms of, with respect from group to group, it becomes a little more complicated because you end up having some very, very small atomic radii. What you used to have small atomic radii, you now have large ionic radii. So that means that in terms of ions, lithium and beryllium, lithium is smaller than beryllium. And then on this side, you have boron as an ion is smaller than fluorine as an ion. It trends in that fashion. Now, I skipped over transition metals because they have multiple types of ions, but generally speaking, they're going to be very small. You're going to have any instance where you have a cation. The cation is always going to be smaller than the anion because anion means that you've added electrons, so the electron cloud is larger. Whereas cations, where you're having a plus charge, which means that you've removed electrons, so the electron cloud is smaller. So think about it in those terms. So coming back to our questions. First, we're asked between oxide and sulfide, so O2 minus or S2 minus. So recall that the trend is down. Oxide is smaller than sulfide. So coming back to our worksheet, we're going to choose our sulfide is going to be the larger of the two. Again, it's very important that you clearly read and completely read the question because it could have just as easily asked which was smaller, and you'd want to be able to identify that. Okay, next we're looking at potassium ion versus sodium ion. So coming back to our table, you'll note that the sodium ion is further up than the potassium ion. So that means that our potassium ion is going to be the larger ion. Now let's look at an interesting case. This is two different copper ions. One is copper 1, one is copper 2. And this takes a little more thinking. Think back to when I just said that the cations are smaller than the anions because they've lost more electrons. And from seeing that, from thinking about that for a second, you'll quickly realize that your copper 1 is going to be larger than your copper 2 because copper 1 has one more electron than copper 2. So the electron cloud is slightly larger. So copper 1 is going to be our larger ion. And that's all there is to it. Just make sure that you take some time and study the periodic table and make sure you understand the trends and why they occur the way they do.